In this portion of the Waves Lab, you will observe interference and diffraction through a single slit, a double slit, and a diffraction grating. So you will use these three different slides. There are numbers at the top of these slides, and those numbers tell you whether you have a single slit or a double slit, the slit width, the slit spacing, and then for the diffraction grating, it tells you how many lines per millimeter you have between the different slits. So the other part of the equipment is a laser. It is an eye-safe laser, but please still do not look into the beam. Eye-safe means just that your reaction time, closing your eyes, is sufficient to protect you from damaging your eyes. Looking at a laser, even if it's eye-safe, will damage your eyes, so please do not look straight at the laser. Then there is also a holder for the slides over here. So I will turn off the lights now so that we can see the diffraction pattern on the screen. So it's going to take me a while to find that diffraction pattern. Aha, there it is. Maybe. So there are 4 different single slits on here. Find the one that you can read best. I think this one is pretty good because it's wider. So this is the diffraction pattern that you're seeing. It's harder to see through the camera than in real life. What you want to do is measure the distance from the laser to the screen, and then mark on this piece of paper where the central bright fringe is, and then where all of the different dark fringes are. And you will then use the diffraction equation. The width of the slit times sine theta is equal to m lambda, and then solve for the wavelength of light. This is what you're getting for the double slit interference. You're really getting 2 different things. One is the broad picture, so that's like the diffraction pattern that you got from the single slit, and within each of those bright fringes you will see the interference pattern due to the double slits. So you're going to have to do 2 things for this. One, within the central maximum you have to count the number of bright fringes, and just like with the single slit experiment you did before, using now d sine theta, where d is the separation between the slits, sine theta equals m lambda, you're going to solve for the wavelength of light. And then just like what you did with the single slit, you will measure the distances between the dark fringes and use w sine theta equals m lambda, where w is the width of the slits. Using that equation, then you will solve again for the wavelength of light. Now for the diffraction grating, you might have to get creative, use maybe like a meter stick so that you can see the various fringes. The central bright is always easy to find, but then you'll have to find more fringes on either side of the central bright. And again, measure the separation between the central bright fringe and the subsequent fringes, and use d sine theta equals m lambda again to solve for the wavelength of light.